Hi everyone, this is our last unit, Unit 5, which is on measurement and geometry. So we're going to be going into our first lesson, which is on Pythagorean Theorem, which actually might be a review for some of you, or brand new to some other people. The goal for this video is to be able to figure out the length of any side of a right angle triangle. And so here's a triangle, and it's specifically a right angle triangle because it has this square right here. Now that square indicates that between the two red lines there is a 90-degree angle. So if you took a protractor and you measured that angle between the two red lines, you're going to get a 90 degrees. You don't have to write the 90 degrees though. As long as you have that square there, people know that that angle is a 90-degree angle. And you can kind of figure it out because the two red lines look like a perfect L shape. Okay, now what I'm going to do is I'm going to just show you how to label all the letters on this triangle. So we use capital letters to measure the corners, or to label the corners, sorry. So any of the corners we usually call capital letters, and you'll see that I did that in black. So capital A, capital B, and capital C. Now when you want to label any of the side lengths, we use lowercase letters. So if you wanted to name, say, this side, you start from capital A and you go to the opposite side, and so you call it little a. And that's something that you do in grade 10 when you learn about trigonometry. Okay, so going from capital B to the opposite side, we're going to call this side little b. And then from capital C to the opposite side, we're going to call that little c. All right, now little c is special because it's actually the longest side, and that's why I colored it in blue. A and B, little b, the reds, are shorter than the longest side, which is the blue line. And so we had given it a specific name. The longest side in a triangle, in a right angle triangle, is called the hypotenuse. All right, so using the two shorter sides and the hypotenuse, the longest side, we create something called the Pythagorean Theorem, which is a formula where we take the shorter sides and we square them and add them together, and they equal to the longest side squared. So what we're going to do is we're going to look at some examples where we're going to use the Pythagorean Theorem to determine the side length x. Okay, now we can't just use a ruler and just measure x because, well, the diagram might not be to scale, so we're going to use the Pythagorean Theorem to find x to 1 decimal place. The very first thing I'm going to do is figure out which sides are the shorter sides and which side is the longest side. So remember that the two shorter sides make up almost a perfect L, so I'm thinking maybe this one and this one look like a perfect L, and that's where the 90 degrees is going to be. So the longest side is going to be this one right here, and that's our hypotenuse. In the second triangle, you have, do you see the perfect L? Yeah, I mean, like, sometimes they move the triangle around, so it makes it look like it's harder, but those two are the shorter sides, which means that's where my 90 degrees is, and my hypotenuse is right over here. Okay, now the last one, can you see where the hypotenuse is? Which one's the longest side? That's right, it's going to be this one, because the two shorter sides make a perfect L, and that's where the 90 degrees is. Sorry, this is a little bit messy. Okay, so let's show you how to solve some of these, and I did 2 of them for you already just to save on the time, but I'll go through them with you. Let's write down the Pythagorean Theorem first. So that's a squared, and you're going to start off all your questions like this, plus b squared equals c squared. Okay, now I've put in red the two shorter sides, so that's 4 and 3, and so in a and b you're going to put the 4 and the 3, and it really doesn't matter if you put the 3 for the a and the 4 for the b, it doesn't matter what order it goes in. Okay, now follow the formula. They had little 2's on the top, so those squares, and a plus and an equal sign right here. So I'm just following the formula above, Now C is our longest side, and it looks like they have an x here. So let's just put an x to follow the diagram. And don't forget the squared. Okay, now you have an equation that has everything, all numbers except for x. So you're going to start to solve for x using BEDMAS. In BEDMAS, we do the exponents first before we do the addition. So 4 squared is 4 times 4, which is 16. 3 squared is 3 times itself, which is 9. And then we're going to put the plus in between and the equals. And we didn't do anything with the x squared, so we're going to write that again. Now we can do the addition, so 16 and 9 added together is going to give you 25. And you have to keep writing the x squared just because we want to see it in every step, because that's what we're looking for. Now in the last step, you want x to be by itself because you want to know what it equals to. But that little 2 is in the way. We have to get rid of it. Now to get rid of it, you're going to do the opposite operation. And so the opposite of a squared is going to be a square root. So those guys are going to cancel each other out, and you're going to get x by itself. But you can't just square root one side. Remember, whatever you do to one side of the equation, you got to do to the other side of the equation too. So we're going to square root that 25, and you have to find the square root button on your calculator. The square root of 25 is going to be 5. So that's your final answer. You just figured out that this guy is 5 centimeters. Okay, so actually, we should probably put a therefore after all of our answers. Therefore, x is 5 centimeters. Okay, now let me go through the other ones with you. So B is exactly the same thing. Start off with your formula, all right, and start filling in your formula. So A and B are the two red sides. Your shorter sides, 13 and 11, so that's what I put here and here. Don't forget the two squares on the top, so you have to put down the two little numbers, the 2's. Okay, and then instead of C, we're going to put x because that's what's in the diagram. All right, now doing BEDMAS, you're going to do the squares first. So 13 squared is 169, 11 squared is 121, and we're not going to change the x squared. Okay, now you can add those two red numbers together and you get 290. All right. Now, do you remember what the last step was to get rid of this little squared? That's right, you're going to do the opposite operation, which is a square root, but you got to do it on both sides. So the square root of 290 is going to be actually a very big number, and so the number, like, it goes on really long. It's like 17.02938 and so on. Now, if you want only one decimal place, you want only one number after the decimal. So check out the next number and see if it's high enough to change that 0 and bump it to a 1. In this case, a 2 is not high enough, and so you're just going to scratch out all those other numbers, and your answer is 17.0. Okay, and I think I forgot to write down, this is in centimeters. Okay, the last question is exactly the same, except I think they just tried to confuse you by making the hypotenuse 15 instead of x this time. But that's okay. We do it exactly the same way. Use your formula and put in whatever is in the diagram. In your red lines, you're going to put into your A and your B. So these two are going to go into your A and your B. All right, and it doesn't matter which order. And then whatever's in your longest line, your hypotenuse, is going to be your C. Okay, so the only difference is this time x squared is with a bunch of other things, but that's okay. So do the exponents first. 3 squared is 9. 15 squared is 225. And you just leave the x squared alone. Okay, now this one requires an extra step of some algebra. I want x squared to be by itself, but it's stuck to this 9. So let's bring it over to the other side, and it becomes a negative. All right, So 225 minus 9 is going to give you a 216. And that's where we do our last step of a square root. And we're going to get 14.7 when we round meters. Okay, so I think you get how to do the Pythagorean theorem, but what does this look like in an application question? So in this question, Chandra uses the map below to determine the distance from home to school. So here's home and here's school, and it looks like you want to determine the total distance that she's going to travel from home to school if she walks along the dark solid lines. Okay, so there's a dark solid line right here, so you're going to have to add that to the dark solid line over here, and then she's going to just, I guess that blue line's like a shortcut. And then also the green line all together is going to be her total distance. Okay, so we have to figure out how long the red, the blue, and the green are, and then put them all together to find the total distance. So I've done the red and the green because it's a little bit easier, and let me show you how I did that. This entire side is 1,200 meters. Okay, so from here to here is 1,200, but I only need it up until here because I'm trying to find this line. So what I'm going to do is, do you see that 400? I'm going to cut it off by erasing it from the total, which is 1,200, or the 1,200. So what we're going to do is we're just going to take 1,200 minus the 400, and then we'll be left with that shorter red piece. All right, let's talk about the green piece now. So the green piece, the total was all of this, 1,100. But I don't need all that. I just need this little piece right there. So what I'm going to do is, you see how like all of this is 900 right here? I'm going to take that 900 and I'm going to cut it away from the 1,100, and I'm going to be left with that little tiny piece, which is the same as this. So what you basically do is you take the total 1,100 and you subtract 900. So that little piece is the leftover, which is 200. Okay, so those are the easier parts. Now we got to address that diagonal part. So this guy, if you'll notice, is like a hypotenuse. Okay, so this is like our x. Here's a right angle triangle with two shorter sides, 400 and 900. So we're going to use the Pythagorean theorem in order to figure this answer out. Let me see if I can squeeze this in here. A squared plus b squared equals c squared. So the two shorter sides, 400 plus 900, equals c squared. Now I'm going to put x instead of my c. Okay, and what I'm going to do is I'm going to do the squares first. So I'm going to get 160,000, there we go, lots of zeros, plus 81 with 4 zeros behind it. So that's a lot of zeros. X squared, I'm sorry if I'm getting a little bit messy. Now we can add those two numbers together, which is 970,000. Okay, and to get rid of that squared, we got to do the last step of the square root. Okay, so I'm getting about 984.9 on my calculator is going to be x by itself. So that's how long this one diagonal side is. All right. Okay, so now that we have all of our sides, we're going to add them together to find the total distance, which is 1,984.9 meters. So you want to make sure that you show algebraically how you got that number, but you also put a therefore statement at the very end. Okay, so that lesson was on Pythagorean Theorem, and in our next lesson, we're going to get into some more measurement. Have a great day, guys.